defining position equation. So we have to make a research and we find the following equation. The problem gives us measure in feet, but in the formula minus 9.8 is in meters over seconds squared. So we have to convert this to feet, and the result is 32 feet over seconds squared. To obtain the position equation for the baseball helmet, we just have to substitute the last formula for the variables already mentioned, and the result is this.
In this question, we have to search the derivative of f of x respectively to x, and we find this formula with limits. Then in our problem ask us to work with time and position. So we are going to substitute the x for the t, that is time, and the f for the s, that is position. So we obtain that s of t is equal to the limit of h to 0 of s of t plus h minus s of t over h. For this formula, we already have this value, that is the position equation that we obtained in the last formula, that it's here. And we just have to find the s of t plus h. For this, we are going to use the position equation, but we are going to add an h to the t's, and just like this. So if we solve this equation, we are going to obtain that s of t. Now we have all the components to make the formula, and if we substitute the s for t plus h is this equation, and minus s of t is our position equation over h. Then if we resolve this, we are going to obtain this equation, and then after this step we are going to solve the h, and at the end the h are going to be eliminated, and we are just going to have that limit of h to 0 is minus 32t minus 16h plus 90. And then we are just going to substitute the h to 0, and if we multiply minus 16 times 0, we're going to obtain that this is going to be eliminated, and our b of time, it's going to be minus 32 plus 90.
Well, we know that with this velocity equation we can find the velocity that the helmet has after any second that we throw it away. And because of the signs, that is minus and this plus, we know that it's a negative parabola from the building to the top, to the bottom, to the floor. So if we derivate this equation, we're going to find first a straight diagonal line. If we derivate more, we're going to find another straight but horizontal line. And if we derivate some more, we're going to find like this. We are asked to find the maximum position on the y-axis, that is the height of the baseball helmet when we throw it away. So the formula we use is from Gmax, is the initial position on y plus the initial velocity of y squared over 2 gravity. So the y max is equal to 700 feet plus 90 feet over seconds, all these 2 squared, over 2 times 32 feet squared over seconds squared. Then the y max is 700 feet, 88,100 feet squared over second squared, over 64 feet over second squared. And if we do the math, this square go away with feet, second square with second square, the result will be in feet. So the y max is equal to 700 feet plus 126.5625, and the y max is 826.
This question, we are going to use the formula of final velocity, that is this. We know that the values of h, VO, and gravity are these, and we have to substitute this in the velocity equation. Then we solve, and we know that the result of final velocity is this. Of derivatives, but in this case we are going to use the velocity equation, not the position equation. After solve velocity equation, we obtain this, and after this without parentheses, and in this case we can eliminate this with this and this with this, and then we have this equation, and we have to solve the h, and then we eliminate, and we have this.
The question is, will the helmet be broken or not? But we know that the final velocity of this helmet, at just a little bit before that it crashed on the ground, is 347 kilometers per hour. We have that it was 230 feet per second. We do all the conversion that this was our result. We know that the record of pitch is like throwing the ball is for Joel Sumaya with 104 miles per hour. Then if we convert this, we get that the record of Joel Sumaya in kilometers is 167.33 kilometers. So we know that the velocity of the fall is 347, and the record of Joel Sumaya is 167. So it's like more than 100 miles above, kilometers, sorry, above one each other. So we think yes, it will be broken.